Welcome back. Yesterday I have given one problem to solve. Yes. See here, in the field of charge Q at the origin, the potentials at all these are given. Is asking at C. Now let us try to get the solution for this one. How do you find out the potential? Potential V is equal to Q by 4 pi epsilon R. So what is the potential at VB at a point B is equal to Q by 4 pi epsilon into 1 by 2 30 volt. Here it is. VB is equal to Q by 4 pi epsilon into 2. How much is that? 15. So from here, what is this? Sorry, this one is VA. Or you can use any one of this. From here, what you're going to get a charge Q? 30 into 4 pi epsilon into 1 by 2. Q is equal to 15 into 4 pi epsilon. So once you have got a charge, I'm going to turn the page here. Can't you find out the potential at C? Potential at C is equal to Q by 4 pi epsilon. What is the distance here? Is 1 meter. But what is the charge Q? It is 4 pi epsilon into 15 divided by 4 pi epsilon. So what is the potential at the point C is 15 volts. But observe the options here. There is no option. There is no 15 volts there. So where we have done mistake? What is missing is a residue. Residue. Why we should consider the residue? He is not asking the potential difference. He is asking potential at a point. So you need to consider along with the residue. So this is wrong procedure. This is wrong procedure. That is absolute potential we have considered. If you want to find out the potential at some particular point, you need to find out. You need to find out potential like this. This formula need to be used. V is equal to Q by yes, Q by 4 pi epsilon R plus K. So what is this VA beta? Q divided by 4 pi epsilon into R. What is R? Here it is 2. Plus K is equal to how much is that? 15 volt. VB beta. Q by 4 pi epsilon. Distance is 1 by 2. Plus K is equal to 30 volts. So how this can be equated? Two equations, two unknowns. Here the charge is unknown, K is unknown. Yes, beta. So two equations, two unknowns, you can find out the charge value and Q value. Charge value and K value. Now what I'll do here, I'll call this as a 2 into VA is equal to 2Q divided by 4 pi epsilon into 2 plus 2K is equal to 30 degrees, 30 volts. I'll call this as equation number 1, equation number 2. I'll do 1 minus 2. Equation 1 minus equation 2. Which is equal to Q by 4 pi epsilon minus or equate those two things. If I equate those two things, what you will going to get? 2Q divided by 4 pi epsilon plus K is equal to Q divided by 4 pi epsilon plus 2K. Bring this one here and that one here. Here it is. K value is Q by 4 pi epsilon. Actually, I wanted to inform one thing. I'm suffering from the fever. Suddenly, I got a fever. I don't know. The throat infection which led to the fever. I don't want it to disappoint you. That is the reason why please cooperate. I'll take 1 hour session today. Okay. So you have got a K value. After getting the K value, you can substitute any one of this one. Substitute in 2 If I substitute in the 2, what you're going to get? What is the equation number 2? It is 2q divided by 4 pi epsilon plus k. What is the k beta? Q by 4 pi epsilon, which is equal to 30. Is that correct? So from here you will going to get 3q is equal to 30 into 4 pi epsilon. So the q is equal to 40 pi epsilon. So after substituting this value there, what is the k value? Q by 4 pi epsilon. Q value is 40 pi epsilon by 4 pi epsilon, which is equal to 10. So you have got a k value. You have got a q value. Okay. Let us proceed further, beta. What is the question actually you are interested here? The question here is, you want to find out the potential at point C. What is the potential at point C, beta? Potential at point C is equal to Q divided by 4 pi epsilon into what is the distance? Is 1 plus K. What is the charge? Substitute all the values. Charge is 40 pi epsilon by 4 pi epsilon plus K value. How much is the K value? Is 10. So here it is VC is equal to 10 plus 10. VC is equal to 20 volts is the answer. Clear, beta? I'm going to turn the page here. Let us have a gradient relation. Gradient relation. Consider V beta. Initial to final E dot dl. So if the electric field is given, this is how you can find out the potential. Yes or not? This is how you can find out the potential. Now I want to do reverse. Now I want to do reverse. If the potential is given, can you find out the electric field? Yes. So potential can be obtained from the electric field by performing what is called a line integral. If you want to get the electric field from the potential, what you need to do? You need to perform the differentiation. But here it is a three-dimensional differentiation. What it is, beta? Here it is three-dimensional differentiation. That means you will going to get what is called a gradient relation. Let us derive this one. But ultimately, what you need to remember is a conclusion box. Clear? So what I'll do, I'll just remove the integration here. So if I remove the integration, what you're going to get? Gradient of V is equal to minus E dot dl. From your mathematics basics, you know that this can be split in terms of x, y, and then z. That means you can write that one as dou v by dou x into dx plus dou v by dou y into dy plus dou v by dou z into dz is equal to minus E dot dl. Okay, beta. What I'll do here, I'll going to split this one into the two dot product of two vectors. How? Observe here carefully. Dou v by dou x into x cap plus dou v by dou y into y cap plus dou v by dou z into z cap. Dot product with dx x cap plus dy y cap plus dz z cap, which is equal to minus E dot dl. What is this one, beta? This entire thing is nothing but a differential length dl. So what I can do, I can just suppress the dl on both sides. I can remove this one here and this one here. I'll going to turn the page here. So E is equal to minus dou v by dou x x cap plus dou v by dou y y cap plus dou v by dou z z cap. I'll take the v common, beta, here. E is equal to minus dou by dou x of x cap plus dou by dou y of y cap plus dou by dou z of z cap into v. Now what is this one, beta? That is nothing but a differential operator del. So what is this E? E is equal to minus gradient of v. Forget about all the mathematics what we have done. For your exam, this is what you need to remember. Clear, beta? Now let us try to have the physical interpretation of this equation. What this equation is saying. Let us try to interpret this one. There is a minus sign here. I have given in the very first class itself, I hope. I think in the second class, we have talked about what is called a gradient. What is a gradient, beta? Magnitude of the gradient is maximum rate of change of scalar quantity in the three-dimensional space. And the direction of the gradient is normal direction. Normal to what? Level surfaces. Clear? So what are the level surfaces here? You will going to get is the equipotential surfaces. What you're going to get is the equipotential surfaces. Yes. So here, what is this minus sign is indicating? It is saying that the electric field direction and potential directions are opposite. If the potential is increasing like this, electric field will be like this. That means electric field act from higher equipotential surface to lower equipotential surface. That minus sign. Let me show you with some simple example here. These are the two surfaces, beta. I'll say a potential of this one is V1. Potential on this one is V0. What these are equipotential surfaces. Let let V1 is greater than V0 beta. What these two are? Equipotential surfaces. So how the electric field acts, beta? Electric field acts from higher equipotential surface to lower equipotential surface. That too normally. So how does the electric field act? Like this? So in which direction it is acting? It is acting in the normal direction. So what is a simple line statement, single line statement for this equation? Electric field projects normally from higher equipotential surface to lower equipotential surface. Let me write down here. Electric field projects normally from higher equipotential surface to lower equipotential. So this is a single line interpretation for this one. This is the interpretation of the so this is the interpretation of this equation, beta. Clear? Let us have some questions on these things. It's a very simple and straightforward question, beta. Simple and straightforward formula. Nothing much to discuss about this one. Clear? So let us have a question here. Where is that one? Yes. Here is a question. An electrostatic potential is given by phi is equal to 2x root y volt. Here it is represented with the phi beta. The magnitude of the magnitude of electric field at x is equal to 1 meter, comma, y is equal to 1 meter is it is a simple and straightforward question, beta. V is a scalar, beta. Shruti, V is a scalar quantity. It is the number, isn't it? 22 volts, 30 volts, something like that at some particular point. It is a very simple, straightforward question. So here V is equal to what it is? 2x into root y. Units are volt. So what is the electric field? E minus dou v by dou x x cap plus dou v by dou y y cap plus dou v by dou z z cap beta. There won't be any differentiation with respect to z beta. So here E is equal to minus differentiation of this one with respect to x. So here it is 2 root y x cap. Differentiation of this one with respect to y beta. So what you're going to get? So what you're going to get? E is equal to minus 2 into square root of y x cap plus x by square root of y. He is asking at a particular point at x is equal to 1 meter comma y is equal to 1 meter. So here it is minus 2x cap minus y cap. He is asking magnitude beta. Four plus 1 square root of 5 volt per meter is the answer. Let us have one more question beta. Yes. It is a substitution kind of question. There is no concept in that, isn't it? E is equal to, the only thing is you should remember this formula. If the potential is given, that is how you can find out the electric field. Clear? Let us have one more question. Two electric charges Q and minus 2Q are placed at 0, 0 and 6, 0 on the XY plane. The equation the equation of the zero equipotential curve in the XY plane is, options are given beta. X is equal to minus 2, option B. Y is equal to 2, option C. X square plus Y square is equal to 2, option D. X plus 2 whole square plus Y square is equal to 16. Yes, beta. What should I do here? Electric charge Q and minus 2Q are placed at 0, 0 and 6, 0 on the XY plane. The equation of zero equipotential curve. Zero equipotential curve in the XY plane is. What is the meaning of zero equipotential curve, beta? On that curve, potential will be zero. That curve may be anything. Let us take some particular point, find out the potential at that point, and make that one equal to zero. Why? He is asking for the zero equipotential curve. Okay, this was your gate question asked for the 2 marks. 2 नंबर का क्वेश्चन था 2016 में. ठीक है, इधर देख, see here brother. Let us draw some coordinate system rough. XY plane beta, that is what mentioned in the question. Here it is X, here it is Y. Where this charge is located beta? 0, 0. The other charge is 6, 0. Minus 2Q. Here it is 6, 0 beta. Where is asking beta? Somewhere here. In the XY plane, he is asking the curve for zero potential. So I'll take some arbitrary point beta. X, Y. Clear? So what is the distance from here to here? And what is the distance from here to here? What is the distance from here to here? It is square root of x square plus y square. What is the distance from here to here, beta? X minus 6 whole square plus y square. Clear, beta? So find out the potential at particular point P and make that one equal to 0. It didn't give any extra information regarding the residue, beta. So consider that residue to be 0 because we are finding the potential at some particular point. There will be some residue, isn't it? But there is no other way for us to find out the residue. Observe the question. Is there any extra information? Any extra information given? No. So we have to consider the residue to be 0. I'm going to turn the page here. What is the potential at point P? Generally, it is Q by 4 pi epsilon r plus K. So consider this residue to be 0 beta. There is no other way. So what is the potential at point P? It is Q by 4 pi epsilon into distance. How much is the distance beta? Square root of x square plus y square plus there is one more charge. What it is? Minus 2Q divided by 4 pi epsilon square root of x minus 6 whole square plus y square, which is equal to 0. Clear, beta? So what happens to this one? Q divided by 4 pi epsilon square root of x square plus y square, which is equal to 2q divided by square root of x minus 6 square plus y square. Yes. Sorry, here it is. Two q divided by 4 pi epsilon square root of x minus 6 square plus y square. Here it is 1 by square root of x square plus y square is equal to 2 by square root of x minus 6 square plus y square. Take the cross product beta here. Let me turn the page here. X minus 6 square plus y square, which is equal to 2 into square root of x square plus y square. Squaring on both sides, what you're going to get? X square minus 12x plus 36 plus y square. 4x square plus 4y square beta. Okay, bring the terms other side. So here it is 3x square plus 3y square plus 12x minus 36 is equal to 0. I'll divide by 3 on both sides. So here it is x square plus y square plus 4x minus 12, which is equal to 0. Go back and see the options beta. This is not the answer. This is not the answer. Not even this one. Why? Because it is something like some extra terms are there. Okay. So this is not the answer. What is the answer? This is the answer. Let us try to adjust that one according to the options beta. Can I adjust like this? X square plus 4x plus y square is equal to 12. Now what I'll do, I'll add 4 on both sides beta. It will become 16. So how this can be written beta? X plus 2 whole square plus y square is equal to 16. That is the thing. Clear beta? Yes. That means on this is giving the circle equation, isn't it? So on this circle of radius 4 meters, center minus 2 comma 0. On that circle, wherever you measure the potential, that will be equal to 0. That is the meaning of that question. Okay, fine. Let us have one more concept here. Poisson's equation beta. What it is? Poisson's equation. What is this Poisson's equation? Consider E is equal to minus gradient of V, gradient relation. Let me call this as equation number 1. Consider divergence of D is equal to rho V beta, where D is equal to epsilon into E. Suppose for the homogeneous medium, epsilon is constant beta. Okay. So if it is a homogeneous medium, I can substitute there. Divergence of epsilon into E is equal to rho V beta. Divergence of E is equal to rho V by epsilon. I'll call this as the equation number 2 beta. Substitute one into what it is? Divergence of minus gradient of V is equal to rho V by epsilon. So here it is del square V del square V is equal to minus rho V by epsilon. This is called Poisson's equation. Okay, beta. And then if the charge in the if it is a charge free region, what does that mean? If for charge free region, rho V is equal to 0, then this equation will be modified as del square V is equal to 0 beta. This is called Laplacian equation. What it is? This is called a Laplacian equation. Okay. Let us have some questions. So what it is? What is the thing you need to remember here? There are number of applications for the Poisson's equation, but we'll not go into the applications of that one, which is not required for our exam. As far as our exam is concerned, you're going to get the questions on the formula based questions. Okay. As far as this Poisson's equation is concerned. But if you take any textbook for the electromagnetic theory, you will solve these Poisson's equations in the different coordinate systems. Okay. There are so many applications for that. We'll not go into the discussion of that. So what kind of questions are expected? I'll going to give here. I'll going to turn the page here. So what you need to remember here is potential and the charge are related by this Poisson's equation. If the charge is 0, this is become Laplacian equation. Okay, let me turn the page here. Okay, beta. The potential distribution is given as V is equal to 10 to the power of 4 plus 20x cube. What is the charge density? What is the charge density? Rho at the point 2, 0. Option A, minus 200 epsilon naught. Option B, 200 divided by epsilon naught. Option C, 200 epsilon naught. Option D, minus 240 epsilon naught. Yes, beta. Directly straightforward question it is. Substitution kind of question. Potential is given, he is asking for the charge density beta. X is equal to 2, Y is equal to 0. So here rho V is equal to or rho is equal to. We know what is the Poisson's equation. Del square V is equal to minus rho V by epsilon naught if you consider. So what is this rho V beta? Minus epsilon naught into del square V. What is this del square V? Dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. Del square V is equal to, there won't be any differentiation with respect to z beta. Double differentiation with respect to x is 20 into 3 into 2 into x plus 10 into 4 into 3 into y square. So here it is. Del square V is equal to, how much is that beta? 240x plus 120 y square. Sorry, 120x plus here it is 120x plus 120 y square. He is asking at a point 2, 0. Just substitute. Del square V is equal to 120 into 2 plus here is the answer. Let us have one more question, beta. I'll give it as a homework question for you. Please try this one. I'm going to turn the page. Charge needed with a unit sphere centered at the origin for producing a potential field V is equal to minus 6 r to the power of 5 by epsilon naught for r less than or equal to 1 is. Options are given, beta. Option A, 12 5 coulombs. Option B, 65 coulombs. Option C, 125 coulombs. Option D, 155 coulombs. He has given the potential and is asking for the total charge, beta. I'll give you the procedure. What is the procedure here? First, you try this one. First, you need to find out the volume charge. From the Poisson's equation, what is the volume charge, beta? Del square V is equal to minus rho V by epsilon naught. So find out the volume charge. So once after getting the volume charge, you can find out the total charge. How it is? Volume integral of rho V into dV, beta. As I said earlier, I'm not feeling well, but I don't want it to disappoint you. That's the reason I took 1 hour session. Please cooperate. We'll continue in the next session. You try this one. Okay, beta. Thank you. There is no tomorrow class. There is no class for me tomorrow. Tomorrow, my class is not there tomorrow. I don't know about other classes. 23rd and 24th. Thank you for your concern. Thank you. Okay, thank you for your concern. We'll continue in the next session.